Section 6.3 is about piecewise functions. Now you see I've got a link here for an image, I guess I could say. It's a GIF, if you will, or if you want to say it incorrectly, I don't care what the creator said, a GIF. Here's what I wanted to show you from that. So here's a dog going after that ball, trying so hard, he misses, but never takes his eye off the ball. So even if at first you don't succeed, try to get that ball again. Anyways, back to this. So section 6.3 is about these things called piecewise functions. Now, a piecewise function is a function that's made up of a combination of functions. Oh, I already have the word there, a there. So it's a combination. I can't write today. Combination of multiple functions. And with that, it's broken up into different domains. So taking a look at this image in the lower right here, this is like two linear graphs where this one's for every place that's like to the right of 2. This one's for everything to the left of 2. So we're going to take a look at a couple examples about how to even like begin processing this. So here's an example about a company that's selling food in bulk. They're selling mixed nuts, so like you can just like scoop them and put them into a bag. So between 0 and 1.99 pounds, it costs $8 per pound. Between $2 and $4.99, it'll be $6 per pound. If you buy 5 or more pounds, the cost goes down even further to $5 per pound. So on this graph here, we're going to have our weight, so our LBs down here, and then off to the right here, I'm not going to have a ton of space, but we're going to do our money over here. Let's just go by one. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8. That should be enough there. And on the vertical axis, I don't have a lot of space. I'm actually going to put it over here. 1, 2, 3, 4, 5, 6, 7, and 8. Now, for the $0 to, or sorry, 0 pounds to 1.99 pounds, essentially that means everything less than 2 pounds. So like at 0 pounds, you pay $8 per pound. Well, that's silly, but I mean, I could go to a store and say, can I have 0 pounds of this? And they're like, yes. Okay, now leave. Now, if I buy 1 pound, it'll cost me $8 per pound. At $1.50, it's also still at $8 per pound. Now maybe I should clarify this. This is dollars per pound. So we're not talking about like how much in total it'll cost. We got dollars per pound. And you'll notice it says 0.99, which means it's going to get really close to 2. Once we hit 2, we got to draw an open circle because once we hit exactly 2 pounds, it's going to now cost $6 per pound. So I'm going to put a dot there. Now from $6 per pound, at 2 pounds, it's going to cost $6 per pound. At 2.5, at 3, at 4, at 4, at 4.5. But once we hit 5 pounds, it's going to get jumped down to $5 per pound. And it says for $5 or more, that means everything to the right of that. So I might switch colors here to make it a little bit more obvious. Or actually, let me just draw a thicker line for these. So up here, we're just kind of looking at dollars per pound. So between 0 pounds and 2 pounds, it's going to cost $8 per pound. Between 2 pounds and almost to 5 pounds, it's going to cost $6 per pound. And then everywhere to the right of 5 pounds, it's going to cost $5 per pound. So the more you buy, the cheaper it is per pound. Not too bad. Here's another example. This one we're going to be given some actual equations that we're asked to graph. So I'm going to wait for AirServe to catch up. But yeah, so this one you've got, and we'll see if we can apply some context to this. This is how we're going to write piecewise functions. So we got f of x equals 5 if 0 is less than x is less than 13. We got f of x equals 9 if 13 is less than or equal to x is less than or equal to 55. And finally, it's 6.5 if x is greater than or equal to 55. Now I'm going to draw a scale here. On the vertical axis, well, we don't know what we're measuring here, so we're just going to go by ones. 1, 2, 3, 4, 5, 6, 7, and 8. And we're actually going to have to go all the way up to 9, so let's add a tick mark there up for 9. So approximately the same distance away. Horizontal axis, we have to go all the way up to at least 55. So I'm going to go, let's just go by fives. We're going to run out of space, but we're going to make another tick mark, and we're going to make it work. So we got 10, 20, 30, 40, 50, and here's our 55, and we're just going to draw based off of that. Now it says it's our y value, our output is 5 between 0 and 13. You'll notice there are no equal signs, it's just strictly less than. So at 0, it would be 13. Well, it actually would be at, there is no point there. But at 5, it'd be at 13. At, my goodness, I'm speaking incorrectly. At 5, it'd be at 5. And we're going to go all the way up to 13. So 13 is approximately there. So I'm going to put an open circle there because everywhere in between, we're going to be at a height of 5. But once we hit 13, then we jump all the way up to 9. So we're going to put a closed dot up there. Now, it's going to be up at a height of 9 for quite some time, all the way over to 55. Now, we're going to have to kind of like overlap with our function here. But once we get to 55, then it says it's going to jump down to 6.5. And so once at 55, it's going to jump to 6.5. And it says for everything greater than that, so it's going to go over this way. Now, kind of putting this into context, it might help if you think about our x values as our ages and our y values as like, I don't know, cost of a movie ticket or something, or the price of a ticket to a, or I guess the price of a meal. Like kids' meals cost $5. So between the ages of 0 and 13, you're considered a kid. And you're going to pay less for a movie ticket. You're going to pay less for an amusement park ticket. You're going to pay less for a meal. But once you hit 13, then scarily enough, you are often considered an adult by many businesses. No 13-year-old I would ever consider an actual adult. But then your price jumps up. So then you're paying more per your movie ticket. So maybe you're paying $9 for a movie ticket. But then once you hit 55 years old, at that point, they often can consider you a senior citizen, even if you're not retired. But the price goes down. It might not go all the way down to like the child levels down here, but it's at least going to be lower. So once you hit 55 years old, your price for your movie ticket gets cheaper again. Kind of putting this a little bit more into context, we're asked to evaluate the piecewise function for a specific input. And so we got to figure out which piece fits in where. So we're asked to do f of 3, f of 9, and f of 100. Again, kind of using the ages. That's like, what's the cost of a movie ticket for a 3-year-old, for a 9-year-old, and for a 100-year-old. So for a 3-year-old, that would mean our x value is 3, which is between 0 and 13. So we go over here and we just see our output is 5. So that means for that 3-year-old, they'd pay $5 per ticket. Now for the 9-year-old, it'd still be in that same range, between 0 and 13. So that 9-year-old, their ticket would still cost $5 per ticket. Now for the 100 years old, well, let's kind of go through. That's not between 0 and 13. It's not between 13 and 55. That is greater than or equal to 55. So that means our output is that 6.5. So in other words, for the 100-year-old person, it would cost them $6.50 to go see that movie. Quite frankly, if you're at 100 years old, I think you should just get into movies for free. But in this hypothetical example, it would cost them $6.50 to go to the movie.